Today we're going to talk about force. And I'm not talking about the kind of force that's a lot like duct tape and that it has a light side and a dark side and binds the universe together. We're talking about force measured in newtons. The Newton, abbreviated with a capital N, is the SI unit of force. And a Newton is equal to 1 kilogram meter per second squared. Sometimes you'll hear people talk about force in terms of foot-pounds and things like that, but our force is measured in newtons, and it's 1 kilogram per meter squared. Kilogram meters per second squared, excuse me. All right. A force is something that changes movement. Okay, think about a change in movement. So a change in displacement is velocity. Okay, but a change in movement, that would be a change in velocity. We call a change in velocity acceleration. So acceleration and force are not the same thing, but they're very closely related. They go hand in hand. Acceleration, if an acceleration exists, there has to be a force. So if there's no acceleration, then there's no force. Alright, the only way you can have an acceleration is if there is a force. The only way you can have a force is if there is an acceleration. And I'm not just saying there are forces all the time, but really it's net force, often written as F net, net force. If there is a net force on an object, that object will be accelerating, no matter what. Alright, now that we know what a force is, we need to talk about force a little bit. So Isaac Newton has 3 laws of motion that are attributed to him. So let's talk about Newton's first law of motion. Newton's first law of motion says, an object at rest remains at rest, and an object in motion continues in motion with a constant velocity, that is, constant speed in a straight line, unless the object experiences a net external force. So basically this just means what we were just talking about, that if we are at rest, meaning our velocity equals 0, if our velocity is 0, that means our acceleration is 0. We're going to stay that way unless we experience a net force. Also, if we have a velocity of anything, but we have no acceleration, if we're in constant motion with constant velocity, we're not going to do anything. We're not going to change that velocity unless we have a net force. So this is really just a reiteration of what I was just talking about. The only way we're going to have an acceleration, that is a change in velocity, is if we have a net external force. That's very important for you to remember. So when that's true, when we have no net force, when the net force on an object equals 0, we call that state, or we'll sometimes call the object, in equilibrium. We call the state equilibrium. Means there is no net force. Means that the object is neither accelerating or decelerating in any way. That is called equilibrium. So I may occasionally ask you for something called an equilibrant force. Equilibrant force. If I do that, I'm asking you for a force that causes equilibrium. So if I say here is a box, it has a force of 20 newtons to the right. Well, the equilibrant force would be 20 newtons to the left. It just cancels it out. Maybe I've got a box with a force of 10 newtons this way and a force of 6 newtons this way. The equilibrant force would be some force off this direction that would cancel out those two forces. So we'd have to figure out what the resultant of this was, and that would be the opposite of the resultant in this case. So I don't think we're going to do that today. We'll see it eventually, I think, though, and that's what equilibrium means and what an equilibrant force is. So know that. Okay, so Newton's second law of motion says the acceleration of an object is directly proportional to the net force acting on the object and is inversely proportional to the object's mass. Okay, so the net force on an object is inversely proportional to object's mass. The acceleration is inversely proportional, and that it's directly proportional to the net force. So what this means in math terms basically is that our sum of all forces, or our net force, sometimes this is written as sigma F. The sigma symbol means the sum of. Either way, net force, or the sum of all forces, equals mass times acceleration. So we have a new formula, basically F equals ma. And you've probably seen this before. This is usually covered in physical science. Force equals mass times acceleration. So this will be really important to know. If I give you a mass and acceleration, you should be able to tell me force. If I give you force on mass, you should be able to tell me acceleration, and so forth. On some of today's problems, I'm going to give you mass, I'm going to give you initial velocity, I'm going to give you final velocity, and I'm going to give you displacement. And I'm going to ask for, not acceleration, I'm going to ask for force. Well, if you have these three things, guess what you can figure out? Acceleration. Now once you have acceleration and mass, you can get force. So don't forget your kinematic equations. They're not going away. We're not done with them. We're not going to be done with them probably until the end of the semester, and even then, not really. They'll still come back here and there. So that's Newton's second law. Force equals mass times acceleration, basically. Now, that's really the important thing to know, but on a test or something, I'm going to put it more like this, or I may even write it a completely different way. I don't want you to just memorize these words and have no idea what they mean. I want you to be able to read some words and say, oh, that's Newton's second law. So it may not be exactly this, but you just need to understand what this means, understand what this is saying. This brings us to Newton's third law. Which states, if two objects interact, the magnitude of the force exerted on object 1 by object 2 is equal to the magnitude of the force simultaneously exerted on object 2 by object 1, and these two forces are opposite in direction. Let me show you what this means. So let's say I have, well, a good simple example is you have a hand pushing against a wall. Okay, and maybe the hand is pushing on the wall with 10 newtons of force. That means the wall is also pushing on the hand with 10 newtons of force the other direction, unless the wall is moving. Actually, even if the wall is moving, then the wall and the hand are pushing at each other with equal force. There's just extra force left over that's being translated into motion. So cancel that. I've got a box sitting on the ground. Maybe the box is supplying a downward force of 15 newtons. That means the ground is pushing back on the box like this with 15 newtons the other direction. Probably down would be negative. Okay, no matter what, whenever something exerts a force on something else, the something else exerts a force back on the something. In every single case, there's always an equal and opposite force. This is often colloquially called something like, for every action there's an equal and opposite reaction. Basically Newton's third law. For every force there's an equal and opposite force, no matter what. There's no free force. Okay, so that's Newton's third law. You have got to know these for your test on this chapter, because I'm going to put them all in the same multiple choice and make up a couple and ask you, Newton's third law states that what? And you have to pick it out. Okay, that's it for today. I got a handful of problems, so get on that.